Hello everyone, good afternoon. How are you today? Have you had your lunch? I hope you are still exciting for this event. It's just day one. We have next day for the last, and then me, Nita, as your moderator for this talk, and in the back, I have Kartika as my co-moderator. Now, we have our speaker is Nicolas Frankel or Nicolas. He is a developer advocate from Hazelcast, and the short introduction of him is a Java geek. Wow, maybe some of you guys are Java programmers too. Okay, and the title of the talk is a guided tour of catching patterns. I will read the overview first. Maybe some of you guys have been using Cage for years, always design application to be responsible for the seeing of Cage and underlying data store. But did you know there are many options available? Well, Nicholas will explain to us in his talk. Ah, I remind you guys we have Q&A session uh, after talk, so you can drop your questions on chat box on Hubilo platform. We will collect them and discuss it in Q&A session. So uh, let's enjoy the talk.
Hi folks, thanks to be here for this talk about a guided tour of caching patterns. I am Nicolas Frankel. I've been a developer for now 2 decades. I also recently became a developer advocate. In the past, I also have been a lecturer at universities and higher education organization. So if sometimes this talk feels a bit like a lecture, it's probably because of this. Also because a guided tour, it lends itself to being a lecture. I work for a company called Hazelcast. Though this talk won't be about Hazelcast, I will be using it to highlight what I'm showing. Hazelcast has actually two big features. The first one, it's an in-memory data grid, meaning you can store data in memory and it's distributed by nature. And the other feature is in-memory data streaming. So you can transform your data, you can enrich your data, combine your data, whatever. Anyway, if you remember one thing from this talk is caching is a trade-off. You might have heard previously that caching is a sign of a badly designed system, that you should shy away from caching, that it's not true. Yeah, of course, sometimes you implement caching because your system is badly designed, but it is as it is, and you must cope with it in the most straightforward way. You cannot redesign every system every time. Now, regarding this trade-off, you have two actually trade-offs to make. So in two contexts is caching a good idea. You accept that you will have stale data because you want fast data, or you accept that you will have data stale because otherwise there is no data at all. And I always use the same example of an e-commerce application. E-commerce application that is designed around microservices. So you would have a catalog microservice, you would have a cart microservice, you would have a payment microservice, a checkout microservice, a pricing microservice. So the customer, they put items into their cart from the catalog, and at some point they go to checkout. During checkout, you will call the pricing microservice again. And because it's a microservice architecture and because it's distributed by Essence, there is a possibility that at this point it takes too long to get the price. And customers or potential customers, they don't like to wait. So they will leave the shop. They won't buy. That is bad. So in that case, it's better to cache the prices of the most used items in the checkout microservice. And if the pricing microservice returns, that's perfectly fine. Then we can cache the price. But if it takes too long, we just go into timeout very fast and we get the price from the cache. And of course, the data won't be exactly the correct data. But from a business point of view, it's better to sell at a slightly outdated price than not to sell at all. And of course, it can get even worse. The microservice, the pricing microservice might not be only slow, it might be down completely. So in that case, it's not about waiting, it's about returning anything. And again, a cache can help us. So remember, the point of view of the business, especially in that use case, is it's better to return slightly wrong data than not return anything at all. Business is happy. Second lesson from this talk is you might have heard about don't roll out your own crypto. Well, don't roll out your own cash. It's going to be a mess. I've been guilty of that in the past. I've been asked, hey, just like make it more performant. And I use the hash map. So in second lesson from this talk, you might have heard the don't roll out your own crypto meme. Well, don't roll out your own cash either. Like, in general, when you're a young engineer, and have been a young engineer, and you are asked to do some caching on some values, you generally use a dictionary. And it works perfectly well until it doesn't. Because the problem of the dictionary per se is it fills out the feature, but it's unbounded, meaning you will put entries into the dictionary more and more and more and more, and there is no limit. So at some point your dictionary will take a huge place in memory and will compete with your application. So first rule, you should set a limit. But it's not only about the size limit. The size limit is the first hard step. The second hard step is imagine that now you have reached that limit and you need to put a new entry into the cache. Which entry should you evict? That's not really cool. You need to think about it. And in general, professional caching solutions, they have multiple strategies for that. It can be least frequently used, it can be least frequently used, it can be a priority that every time you set an entry into the cache, you can give it a priority. There can be even a plugin, a custom plugin, so you can plug in any strategy you would like, but this is something you need to address. Also, when you set an entry into the cache, in general, it's good for a certain time frame. Afterwards, that entry should be invalidated. There should be a background thread that removes invalid entries. And again, that's something, if you roll out your own cache, you need to develop by yourself, and it's not fun. This is related to time to live concept. Again, when you put an entry into the cache, it's valid for a certain time. So either it's per entry or it's per cache region, but anyway, you shouldn't put an entry into the cache forever. Then there are optional features, something that might be also interesting, though you probably won't need it every time. So some caches, for example, they are distributed. That brings a new level of problems, because once you start having distributed cache, you probably want to form a cluster, and so there is this auto-discovery problem. How do you find your other nodes to form a cluster? And then, because we are talking about distributed systems, you probably have heard about the split brain. Split brain is, hey, there is a network partition, and there are clients that are still using the cache, and at some point the cluster reforms again, and what are the valid entries? How do you work with that? That's a completely a new level of issues. Then when you put stuff into the cache, how do you serialize them? Do you serialize them according to a dedicated stack, like Python or Java or whatever? Or do you serialize them in JSON so that you could have like a cache that is accessed by different clients in different stacks? So let's start simple. I have an application and I just want to cache some stuff. And the easiest way is your application will be the orchestrator. So the application will first get the value from the cache. And if the value is null, meaning there is nothing in the cache, or there might have been value in the past, but it had been invalidated. Anyway, right now, the cache is empty for this value. Then we will get to the data store. And in general, the store is the database, but it can be anything. And then you get the value from the data store. And if you find it, because there is a chance you don't find it, then you put it in the cache. And then you return it to the client. And the next step is now the client gets the same entry from the cache, and it's here, and it returns immediately without going to the data store. So let's check how it's done. So here I've created a simple Flask application. I have a couple of routes. The first route gets all entities from the database. The second route gets one by its PK, by primary key. And I also have a third route that allows me to put entities into the database. I mean, it's a simple CRUD application. I will be handling person, and before I start the application, what I will be doing, I will be populating my database with dummy data if the database is not already populated. I'm using SQL Alchemy, and I'm using SQLite to put the data. Of course, it's not how you would do it in production, but it's for simple demo. So let's start it and let's see how it works. So I can curl local hosts 5000, and I will get all entities here, and you can see that they correspond exactly to what I created because it's a brand new database. Or I can ask for one PK, or I can try to put some data into it. So curl post local hosts 5000, and now I must remember the syntax. It's header and it's content type application JSON, and I will pass in this following data. And now if I curl again for everything, I will get this new entity. I don't need HTTP localhost 5000. Yes, and now I have this new entity that is created. So I'm very happy. I have an application that works, but for whatever reason, it's too slow, and I want to implement caching. So I go to my faithful IDE, and here I already created everything because I mean it's too dangerous. So I will be using Hazelcast as I mentioned, and the only thing that I'm doing, I will create a Hazelcast client, and from this client I will get a dedicated map. By default, we have a non-blocking behavior, but here I want to have it as simple as possible. So I will create a blocking cache. So every time I put a stuff into the cache, I can directly get the result. And this is how it works. When I get all, for every person that I got, I put it into the cache. I write it down into the log just to be sure. And when I get one, I will get the PK. I will check if the cache contains the PK, sorry. And if it contains it, I return it from the cache. Otherwise, as I mentioned, I will write it down into the cache and return the person directly. So let's see how it works. So here I will first start my cache as a cost starts. So I already installed it. Again, it's not about showing you Hazelcast. It's just imagine that I have a cache running. It's a distributed one. And now I can start the application. And I can curl it. So curl localhost 5000, get first entity, and it returns me Joe Dalton. And at this point, I should have like person with PK1 not found in the cache, person with PK1 set in cache. If I ask it again, the same key, then I have PK1 found in cache, so I don't go to the database. And of course, I can curl everything, so now every entity is in the cache, and if I ask for a new one, then all entities are in the cache because I've set them all, and now a PK1 has been found in the cache, so you don't go to the database again. That's actually the cache assigned. And of course, it's only about reading, but we can also do the same for writing. And this is actually even simpler. So every time you write in the database and you check that it works, of course, then afterwards you can set it in the cache. And in the code, it's the following translation, like we commit, and at this point, if there is no error, we can set the key in the cache. So here we will create a new entity again, H, and I just want to create Jake Do, for example, because John has already been created. Okay, and now I want to curl everything, localhost 5000. We can see Jack, and it's in the cache. Perfect. That seems easy enough. And actually, you don't need any real like caching provider for that. Any hash map will do in that case, even though you need a limit, you need an invalidation strategy, whatever. it's, I mean, it's straightforward. This is in general what people think about when they are using cache. But the cache can be so much more. So that's the first pattern, is cache aside for read and write. The second pattern is actually read through. And we read through, you actually are not orchestrating. Your application is not orchestrating. What you are doing is you are only interacting with the cache itself, and the cache is configured to talk to the database. So on one side, it might be beneficial because you actually only talk to the facade of the cache. On the other side, you need to configure the cache accordingly. You need to be sure that the cache works according to your needs. Let's see how it works in the code. So for convenience purpose, I've created a new project with the cache itself because it will allow me to do some changes. And in that case, the change is the following. So normally you would just use again the cache, and you would like write the code and then you won't care about it, because I think that's important for you to know. Right now I've created a new project. In that case, it's a Java project, but the idea, even if you are a Python developer, is quite straightforward. The idea is we have this stuff called SQL map loader, and basically what it does is when we are calling this like load, and we won't be calling it explicitly, it will be handled by the caching provider itself. It will look into the database. And of course there is a load all, and of course afterwards there is a load of key. I mean, there are a lot of methods that you need to implement. Well, not that many actually. If we look, there is this load all keys, and of course there is some initialization stuff. And because here I want to say, hey, I want to read from this database, but once that it's done, we should forget about it. We can just run the cache, and we will have this application. But as you can see on the routes, we are not interacting with, sorry, not here. Of course, here we are still interacting. Here, we are not interacting with the DB anymore. So we moved the code that interacted with the DB from the application to the cache. So now that our application is actually much simpler. And what we do is just, like read from the cache, and the cache will be the one to say, oh, it's not in this cache, so I need to load it from the DB. It will retrieve it from the DB, put it in the cache, and return it to the application. The application, in turn, will just like get it. Likewise, you can do the same for the PK. So let's see how it works. I can now call the application localhost 500/1, and I get directly the entity. If we check from the Python application, of course, there is no logging. We directly get the stuff. And on the caching provider side, we can see that we have been loading some data already. We are eagerly loading. It's not necessary, but we are eagerly loading. On the sides of the writing, we are still interacting with the database because we are only doing a read through. We are not doing write through. So the next step is, so let's see write through. And again, it's the same as before. We are interacting only with the cache, and the cache itself interacts with the data store. So let's simplify our code using write through. That requires the next step. And in that case, now this map store, this class implements a new interface, which is called map loader. Again, this is Java code. I don't want to go into the detail, but it adds a couple of additional methods. Actually, store all, and also, yeah, I'm too lazy to implement this now, but and then you can also do the delete stuff and the delete all stuff. So let's start the cache with that in mind. And afterwards, we will be able to start the application itself. Okay, so we can still curl, everything is fine. We can still curl everything is still fine. And now we can post, and post will be doing right through. So curl, I will be doing that because I'm lazy. Okay, and I had John, I had Jack, now I will have like Jane do. And here I have an issue. I don't get the ID of the entity because now I've migrated my store logic to the cache. So here I need to provide the ID, which can be an issue in some cases, but here, let's suppose it's not. I will be using ID 10. Now it works. And of course, we curl ID 10. It's already in the cache, because again, we are only interacting with the cache right now. That's pretty good. So far, I'm quite happy. Notice, however, that in that case, what we are doing is every time we are waiting until we get confirmation. So here, this is, if you remember your UML lessons, this is synchronous. So we put data into the cache puts data in the data store, and we wait until the data store has done its job and we get the response and we return the response. And it might be good, depending on your use case, it might be not so good. We are not that fast as we could. So the next step is, once you have implemented right through it, to say, hey, but perhaps we could be much, much faster. How much faster can we get? Well, it's easy. When you put stuff into the cache, you just return immediately. And you leave it up to the cache to put the data in the data store. And again, it has benefits and it has disadvantages. Benefit, of course, I mentioned it. It's like super fast. You are only interacting with the cache and you return immediately. Problems, that you are not guaranteed that actually this will happen. There might be some issue with the caching provider. It might go down. There might be some issue with the data store. It might go down. So you might have wrong value in the cache, and the client thinks that everything has been done in the right way. So this is eventual consistency, and sometimes it might not be consistent at all, but you are fast. And again, it's not bad per se, but there are some use cases where you value like speed over consistency. It's up to you to decide, but this is right behind. So you are just saying, okay, I will do everything asynchronously. Let's see how it works. So here we go to right behind, and actually the only thing that we need to change is how we configure. In that case, that's very Hazelcast specific, we just need to change a single line of configuration. We just said that there is a write delay seconds. So between the time that you actually do a change and the time that the change gets triggered to the data store, there is 20 seconds. And the good thing is that during that time, there might be other requests coming in for the same entity. So there will be only one call to the data store, the latest one. Again, pros and cons everywhere. The next pattern that I want to show you is refresh ahead. One of the problems of the cache that I mentioned is you've got stale data. In order to cope with stale data, we are doing cache invalidation. So when you put an entry into the cache, you set it's like valid for a specific amount of time, let's say 5 minutes. Afterwards, that gets cleared, and next time your client gets the entity, the entry, it's not here, so we need to fetch it from the database. And at that point, we need to do the whole flow, and it takes time. So you will probably have like long requests that need to access the database and, like slow requests that need to access the database and fast requests when you hit the cache. That's not a necessity. What you can do, again, with some caching providers, is that when an entry is close to invalidation, then there will be an eagerly fetch from the data store. So again, that is asynchronous. Your client doesn't know anything about it, but once you've put an entry into the cache, it will be refreshed automatically when it's close to expiration. So if you set the invalidation period to 5 minutes, like when it's close to 5 minutes, we'll fetch the data from the data store so that you know that every time the entry will be like, we'll have the latest stuff from the latest 5 minutes, but more importantly, the client will fetch the data always from the cache. And of course, the problem in that case is that your cache will always be full. So once you've put an entry into the cache, it will stay there forever. Because you can only grow, because you never invalidate anything. When you invalidate, you put it again. That's pretty good if you accept this trade-off. But that means still that the first request will still be slow, because the first request there will be no entry at all, and you will need to fetch from the data store. Now imagine that we will pre-populate the cache with everything. That could be a pretty neat idea. Again, if you've got like a lot of storage, if memory is not an issue, we could pre-populate cache. That's a pretty good idea. But once we've populated the cache, we need to update it. And again, refresh ahead is a good idea. But if we set the time to live of 5 minutes, that means that there is a time span in which, a time window in which the data won't be valid. So when you start thinking in frames, in windows of time, and you have an issue with that, probably that's not the right way to address the situation. In that case, if you really want to have like the window of inconsistency between the cache and the data store to be as small as possible, you should be event driven. You should be, every time there is a change in the data store, it can be reflected in the cache. That's another level of complexity, but it works. But for that, we need an additional property. We need to have streaming. So we will have streaming that gets the changes from the data store and every time there is a change, it will set the value in the cache. And on the application side, not only we will interact only with the cache, but the cache itself won't fetch the data from the data store. So everything has been like moved to another component. Now it's this streaming pipeline's job to get the data from the data store and into the cache. So it's another level of architecture complexity for another level of benefits. Let's see how it works. Now, the cache itself is not necessary anymore because, as I mentioned, the cache itself doesn't interact directly with the database. So we can remove this one. There is no like SQL map store. What we have created on the opposite is a cache head stuff. So again, this is Java code. I don't want to delve into the specifics, but we've created a pipeline. And even if you are not a Java developer, you can read, hey, read from MySQL, and I will map. So here I have an object called change record, and then I will change, like I will transform the change record to a map, and I will transform the map to a JSON, and from this JSON I will extract the ID, which will be the key, and put this entry in the cache. And well, the rest is not super interesting. Basically, it's just like configuration to say, hey, where do we get the data from? So here I'm using MySQL because SQLite is not made for that. So hey, here it's the host, it's the login, it's the password, blah, blah, blah. And here we are just configuring where we will write to. So it's a remote cache. For that, I have created a Docker Compose file. So here you can see, here I have my cache. Very simple cache. Again, I'm using Hazelcast. You can use anything you want. Here I have my application that I have Dockerized. And here I have the pipeline. And everything has been Dockerized. And of course, I have the database. So let's start this. It might take a bit of time, of course. So let's do some magic. I'm ready. I can start playing with my application. So here everything is Dockerized. I don't need to start it in the IDE. I can directly like curl. Let's do that. So let's say curl localhost 5000/1. Good, I got it. And you can see it's like, I wouldn't say blazingly fast because I don't like this term, but very, very fast. And let's say here I want 2. And as you can see, again, it's very, very fast. If I get everything, it's very fast. I have an issue with the formatting. And then the last stuff I want to post. So let's post something. H. And here I'm on a new application, so I can put everything like this. And if I curl localhost 5010, it's already in the cache. That's our latest pattern, cache ahead. So here is a summary. In this talk, I've shown you several patterns to interact with your cache. The first one, as all developers do, is the cache aside. The cache aside, you don't care about the capabilities of your caching provider. Your application is the orchestrator, and then you go to the data store and you go to the cache to read and write. And it's your application's responsibility. Once you get comfortable with your caching provider, in general, you will use read through and write through because it removes the responsibility of this orchestration flow from the application. Your application doesn't care about the cache. It should just like use one data store, and in that case, the data store can be seen as the cache. At some point, you might be faced with performance issues you are blocking. If you don't have solid consistency needs, then probably you will need to check write behind. With write behind, when you are hammered by several requests on the same entry, what you do is you defer the writes asynchronously, and then you will only write the last one, which makes your system much more resilient. If you value consistency, if you don't like the fact that the data you return might be stale, if you value the fact that your application is fast, you might know that every time that the cache is called, you will need to go to the data store. In that case, you might say, hey, once I've requested an entry has been put into the cache, there might be slow pass. So when this entry has been invalidated. So one idea is once an entry has been put into the cache, when it's nearing invalidation time, you will refresh it asynchronously. And in that case, once an entry has been put into the cache, there will be only fast requests because you will be always eating the cache. It will be a hot cache. That, of course, means that you will have memory available. The problem is it doesn't handle new data. Now, if you've got a lot of memory and you want this window of desynchronization between the cache and the data store to be as small as possible, you can have cache ahead. And in that case, you remove everything from your application and you remove every logic from the cache itself. And you are just creating a new pipeline that will read the changes directly from the database and put them into the cache so that your application actually will consider the cache as the data store, and you know that this cache is very, very closely in sync with the data store. It's not completely consistent because we are talking about distributed systems, so it can never be consistent as you would think about ACID, but the window of inconsistency is as small as possible. So I thank you a lot for your attention. You can read my blog, you can follow me on Twitter. This talk was based on a blog post I wrote, so if something is not clear or whatever, you can check the blog post. More importantly, if you want to check the codes, everything is on GitHub. It's freely available, so please have a look. And if you have comments or issue or whatever, I will be very happy to read them. And if I got you somehow interested in the Hazelcast, you can join our Slack or get some free training. Hello.
Hello.
Do you hear me?
Yes, we can hear you.
Perfect.
What is it?
Hi, everybody. Sorry, we have technical issue at the moment. So I hope everything will be again.
Okay, so I think the moderator has an issue, so let me assist to handle this session.
By the way, hello, Setya. Since we've never met, it's the first time we see each other.
Hello, hello. Yeah, it's good to see you finally, right? Okay,
Finally, yeah.
oh, by the way, we have questions here.
Mm-hmm.
Hang on. Let me transfer the question first.
What's a strategy to cache and invalidate get-list endpoint with query params, such as filter and page? And here I think there is a confusion because the cache has different meanings. I assume that here the cache that Aditya Dharmawan refers to is actually the cache on the client side, so HTTP cache. And my talk was actually object cache on the server side. So there are unrelated concerns in that case. So my talk is not related to client-side caching.
All right, all right. So if Aditya can verify a bit further about the question, you feel free to ask another question. And then we also have second question for Irfan Putra. I see you used the Zoom for change data capture. What else do you have in Hazelcast Jet Cache refresh?
Yeah, actually, it's a very good question. So I didn't want to get into the details, but yes, the streaming engine, the Hazelcast Jet streaming engine, reads data from somewhere. You can put like steps to transform, to filter, to whatever. Then you write data somewhere else. And here, what I'm doing is the source is actually the database through change data capture with Debezium. Then I do the transformation or not, depending on the format I stored it in. And then I write in the cache directly so that I always have a cache that is evergreen. If you don't want to delve into this level of complexity, but of course it's like the Rolls Royce, but it's complex to set up because that means you need to have an additional cluster to set up, and perhaps you don't want that. You can easily get some. We have listener life cycles on Hazelcast proper. It's not about Hazelcast Jet. It's just on Hazelcast proper. So you can do stuff when your entry expires. One of the things you can do is, hey, I will explicitly like check it again, perhaps to send a signal to say, hey, I am expired, perhaps you should do something about it and perhaps create a new entry. But yeah, there are different levels, and for a cache refresh, I think the solid way to do that is through Debezium and Hazelcast Jet in this demo, in for example. Again, I don't want to like be pushing Hazelcast, though I'm working for Hazelcast. I don't want to push it too much because as an engineer, I don't like sales pitches, so I don't want to do a sales pitch again.
All right. Okay, looks like we don't have any other question, but yeah, it's quite interesting actually about Hazelcast. Like, seems like you offer lots of services
Yeah.
in Hazelcast. Like, maybe can you describe a little bit further about like what is your main services that provided with Hazelcast?
That's the issue. So in the introduction, I mentioned Hazelcast. For me, the video at the beginning was a bit like not great. So perhaps I will explain it again here. So Hazelcast, it's a platform. And actually, we have two services. The first one is we store data in memory, but distributed. And the second service is Hazelcast Jet. Before it was like a separate product. Now it's everything into the same platform, and it does the streaming stuff. So we can handle data at rest and data in motion. And one of the most used way to use Hazelcast is actually caching, because you can store data in this Hazelcast cluster and retrieve it. So you have like different clients, you store the data, it's a cluster, so you can add as many nodes as you want, you can configure to have as many backups as you want, and then you retrieve the data from another node, which is super, super useful. One of the like easy classical use case is to do session replication. So imagine you don't want to store the state in one of your nodes because Normally you have a load balancer in front of your web servers and your application servers. And then what you don't want to do is, if one of the nodes dies, then you don't want to lose your session. So one of the use of Hazelcast in that case is you store the session data in Hazelcast. And because, again, like Hazelcast is distributed by nature, you can replicate as many backups as you want. So you say, hey, I always want to have like at least 2 backups just to be sure. So it's a bit slower than, of course, that if you had no backup, but you are guaranteed, or let's say the probabilities are very high that you keep your data all the time. And so if one of your like web server dies or application server dies, then it's not an issue, because the other web server or application server, it can access the session data from the cluster. And so your users, they don't see the difference. There might be a slow lag because one of your web server or application server has died, but then it's business as usual. So if you are doing like stuff that really requires you to have the session data everywhere, such as e-commerce, because you don't want, if a customer like is shopping as like items in their cart, you don't want them to be redirected to another node and then lose their card, because hey, you will be doing e-commerce very wrong. Then it just increases the reliability of your system as a whole. So like reliability, caching, this kind of stuff, you can use Hazelcast. The thing is, it has so many use cases that it's very hard to describe everything. In one of my talk, for example, I'm also using change data capture. I'm using change data capture to do zero downtime deployment, so that the customers, they are using one database for an application server, and then I stream change to another database, and with a schema that has been changed. And then when the customers, they are redirected to this new database, everything is as they expected it. So you can do really, really a lot. I like encourage you. I have some other talks, but they are mostly in Java or Kotlin. So sorry, this is my only Python talk. But we have a Python client, as I've shown you. So everything that I do, you in the JVM world, you can do as well in the Python world.
Okay, wow, that's amazing. That's fantastic that you made it. It's awesome. So
Thanks
thank
a
you
lot.
so much, Nicolas, for the talks.
Thanks.
We do really appreciate your session, and yeah, we do really apologize for some technical issue that we have encountered. But yeah,
It
it's
happens.
awesome talks. We also have to record it so people still can enjoy your session as well. Thank you,
And
Nicolas.
I hope that
See
next
you.
year or in 2 years, I will be able to do this talk live or another talk live at
Yes.
PyCon
Welcome to
Indonesia.
Indonesia. Come.
I will be happy
We are
to.
looking forward to
Thanks a
have you
lot.
in person. See you. Bye-bye.
See you. Bye-bye.